Okay, these are the answers to Blue Workbook, page 62, where we are going to go over the effects of a solute on the properties of water. And we are going to compare the freezing and the boiling point of different solutions. So you're going to see we're given different solutions and they have different concentration. And they're asking us, how is this one affecting the boiling point and the freezing point? Let me just give you a quick review. So let me just explain this. So when you just have pure water, we know that the freezing point of water is 0 degrees Celsius and the boiling point of water is 100 degrees Celsius. What I want you to understand is that the moment you have water and you add anything, whether it's a salt, sugar, any type of chemical, okay? So let's say a solute, now you have a solution. What's gonna happen is the boiling of water, when I add salt, it's not gonna stay at 0 degrees Celsius, but it's going to be lower than 0 degrees Celsius. And the boiling point of water, it's not gonna stay at 100, but it's going to increase and it's gonna be higher than boiling point. So let's say, now, how much is it going to decrease and how much is it going to increase? So we call it all depends on how much of that salt or of that chemical we add it into the water. The greater the number of moles, the greater the number of particles into the water that are dissolved, the lower the freezing point, the greater the boiling point. So because the freezing point is decreasing, we call it freezing point depression. And because the boiling point increases, we call it the boiling point elevation. Now, what did we say? So if I have just water, the freezing point is 0, the boiling point is 100 degrees Celsius. Now, if I have water and I have ions, I add, let's say, NaCl. It's going to be Na plus and Cl minus. But let's say I add AlCl3. Now this is going to break down to 1 Al plus 3. And how many Cl minus? 1, 2, and 3. So we're going to see that this one plus water, this one has less ions than this one. This one has more ions. This one has less ions. How is this? Does this play a role? What I want you to understand, less ions, less change. More ions, more change. So between those three, pure water, less ions, and a lot more ions, we're going to say that this one, because it has more ions dissolved, and because they interfere with the boiling point and the freezing point, we're going to say that this one is going to have the lowest freezing point and the highest boiling point. So we're going to say more ions, or in other words, greater concentration. And how do we measure concentration in terms of molarity? The lowest the freezing point, the highest the boiling point. The lowest the freezing point, the highest the boiling point. Let's go back to our reference table. Let's do new share. Let's go back over here to our page. What do we see over here? We are going to see that they are all having the same molarity. So when you're looking for the change, I want you to look at the molarity, and I also want you to look at I, the number of ions. We're going to see KBr forms K plus and Br minus, and they're all K. They're all the same one. So they're all having 2 ions. So it all depends on the molarity. Now, which one has the highest molarity? We're going to see that this one has the highest molarity. So it has the greatest concentration. And we will see that actually this one has the lowest molarity. The highest molarity, the highest the concentration, what does it mean? The lower the freezing point, the higher the boiling point. So out of them all, this one is going to have the lowest freezing point and the highest boiling point. Now, the one that has the lowest molarity is going to be the reverse. It's not going to have the lower freezing point and the highest boiling point. It's going to have what? The highest freezing point and the lowest boiling point. Let's move on to the next one. What do we notice? Now, we see that this one has 1 molarity, this one has 2 molarity, this one has 1 molarity, and this one has 2 molarity. Now let's look at the ions. This one is NaI, so it's an ionic compound. It breaks down to 2 ions, so therefore it has 2 ions. This one is again an ionic compound, breaks down to the ions, therefore it's 2 ions. This one is molecular, it stays together, and molecular stays together. Molecular is when you have a non-metal, 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 non-metal. They stay together. So it's 1 and it's 1. What did we say? It all depends. The concentration is going to depend on the ions times the molarity. So 2 times 1 is 2, 2 times 2 is 4, 1 times 1 is 1, 1 times 2 is 2. So we're going to see that this one has the greatest concentration and this one has the lowest concentration. So the greatest concentration, the more ions it has, the lowest the freezing point, the highest the boiling point. So you have to remember that. This is what the Regents is most likely going to ask. The greatest the concentration, the lowest the freezing point, and the highest the boiling point. Now, this one is going to be the reverse. It's not going to have the highest boiling point, but it's going to have the lowest boiling point and the highest freezing point. I hope it's not confusing, but the main thing the Regent is asking is the greatest the concentration, the lowest the freezing point, the highest the boiling point. Let's move on to set 3. Let's do the same thing. This is ionic, breaks down to Na plus and Cl minus. This one breaks down, if I am going to do MgCl2, and it breaks down to Mg plus 2 and Cl minus, I will see that I have 1 Mg, and how many Cls? 2. Therefore, how many ions is it forming? 1 plus 2, 3 ions, Mg plus 2 and 2 Cl minus. So this is 2 ions, this is 3 ions. How about over here? This is AlCl3, breaks down to Al plus 3, and how many chlorides? 3 Cl minus. 1 and 3 is 4 ions, so we're going to write them. So we're going to have 4 ions over here. This is molecular, stays together, is 1. Then we're going to look at the molarity. The molarity for this one is 0.1, 0.1, 0.1, and 0.1. So we're going to see that this is going to have the highest concentration, and the one with the lowest concentration is going to be this one. So let me just change the color so we can see. So this is going to be the highest concentration, and this one is going to be the lowest concentration. Highest concentration, what does that mean? Lowest freezing point, highest boiling point. So lowest freezing point, highest boiling point, and then this one is going to be the reverse of this one. So it's not going to have the highest boiling point, but it's going to have the lowest boiling point and the highest freezing point. Let's go to set 4. We're going to do exactly the same thing. The ions, how many ions? It's going to break, how many K plus? 2K plus. And how many SO4 minus? 1 SO4 minus. So therefore 3 ions. NH4 plus and Cl minus, 2 ions. K plus and NO3 minus, 2 ions. And this is molecular, it stays all together. So it's 1, it stays as CH3OH. What is the molarity over here? 2. The molarity over here is 1. The molarity is 2. And the molarity is 1. 2 times 3 is 6. 2 times 1 is 2. 2 times 2 is 4. And 1 times 1 is 1. So this one has the highest concentration. The higher the concentration, the lower the freezing point, the higher the boiling point. Lowest freezing point, highest boiling point. Which one has the least? This one. So what is this one? The lowest freezing point? It's going to be the reverse. It's going to be the highest freezing point and the lowest boiling point. Let's move on to the last one. Okay. The last one, it's a little tricky, but okay. So we're just going to look at the numbers: 200 milliliters, 300 milliliters, 300 milliliters, and 200 milliliters. And we're going to see that we have the same salt. It's an ACl. So this one has 3 grams, this one has 6 grams, this one has 3 grams, and this one has 6 grams. 3 times 2 is 600, and 3 times 6 is 1800. And 900 and 1200. So we're going to see, this is 6, this is 3, right? Okay, so we're going to see that the lowest, this has the lowest concentration. And this one has the highest. Right? Yep. Okay. So we're going to see which one has the highest concentration, this one. So therefore, we're going to say that it has the highest, it has the lowest freezing point and the highest boiling point. And this is going to be the reverse. It's going to have the highest freezing point and the lowest boiling point. So all you have to remember is this. Just write it down in your notebook on the page that you're doing. Okay, so you're going to write down highest concentration. That means lowest freezing point, highest boiling point. Thank you for your time and your patience. See you next